Assalamualaikum warahmatullahi wabarakatuh. To respected lecturer Dr. Wanur Aifa, Dr. Farah Nadia and Dr. Khairia. My name is Fatih Nadia. Today I would like to present my final year project on the title of Stability and Flow Performance of Porous Asphalt Mixture Incorporating with Waste Cooking Oil. This presentation comprises of 4 chapters, which is Chapter 1 Introduction, Chapter 2 Literature Review, Chapter 3 Proposed Methodology, and lastly, Chapter 4 Conclusion. Chapter 1 Introduction. Porous asphalt is also known as open graded hot mix asphalt. It has pervious and permeable structure and consists a slight amount of fines as correlated to the dense asphalt mixture. Not only that, it also contains about 20% of air voids. Why should we use porous asphalt? This is because porous asphalt contains many advantages rather than dense asphalt, such as rapid drainage, elimination of aquaplaning, secure the road safety and durability by the improvement of skid resistance and friction, reduce the reflection and headlight glare at night, and lastly, reduction in noise. Problem statement. The problem statement is related to the waste cooking oil. Malaysia is a popular country for food. Due to the high demand of food, it will generate tons of waste cooking oil. The chart presented the production of waste cooking oil from different countries. It shows that US produce the largest amount of waste cooking oil, which is 55% from the overall production, and Ireland is 1%. Meanwhile, Malaysia is 3% annually. The improper management of waste cooking oil will cause many problems, such as the environmental problem, which is the awful odor. Past researchers stated that 1 liter of waste cooking oil can contaminate about 500,000 liters of water. Besides of that, it will also increase the amount of organic load and produce a thin layer liquid on the surface of water. This organic load and thin layer liquid will eventually decrease the amount of dissolved oxygen in the water and threat the aquatic life. Lastly, it will also impact the operational and sewerage system. For example, the waste cooking oil that is dumped into the sink will be solidified and more amount of cost will be allocated for the wastewater treatment and in water treatment plant for treating the waste cooking oil. The objective of the study is to determine the parameter of waste cooking oil in terms of free fatty acid and water content. Secondly, to evaluate the chemical treatment for waste cooking oil through the process of transesterification. Thirdly, to analyze the physical performance of asphalt binder incorporating with waste cooking oil by penetration and softening point test. And lastly, to validate the performance evaluation of porous asphalt mixture incorporating with treated and untreated waste cooking oil in terms of stability and flow. Chapter 2, Literature Review. The literature review is comprised in the table of comparison that differentiate the studies and laboratory results from 5 different researchers in terms of performance in penetration, softening point, and viscosity. For the penetration, as the amount of waste cooking oil increases, the penetration result will also increase. The stiffness of asphalt is weaker when too much WCO is added, especially when more than 5% of WCO is incorporated into the mixture. In point of view for softening point, the softening point of the sample becomes weaker when WCO is added. Lastly, for the viscosity, at various temperatures from 110 degrees Celsius to 180 degrees Celsius, the asphalt with WCO has much lower viscosity than the conventional asphalt. Not only that, the flow tendency of the sample also decreases as the amount of WCO added increases. Meanwhile, a study conducted by Hossein and Ahmad displayed that the sample with treated WCO has the highest viscosity than the untreated waste cooking oil. Chapter 3, the proposed methodology. The methodology is presented in the flowchart. There are three phases. of metallurgy and the study, which is the first phase is the chemical treatment of WCO. It is started with the filtering process, then preliminary test to check the quality parameter of WCO in terms of acid value and water content. And lastly, the pre-treatment using the transesterification. The second phase is the modified binder evaluation. It is to test the physical properties in terms of penetration and softening point test. And lastly, the phase 3 is the asphalt mixture evaluation to test the mechanical properties using the Marshall test of flow and stability. Phase 1, chemical treatment of waste cooking oil. It is the filtering process to remove physical impurities and debris using filter paper. The preliminary test is the acid-base titration analysis, which is to test for free fatty acid in waste cooking oil. It is in accordance with ASTM D1980 to determine the end point of a solvent by adding a solution until an equivalence point is reached. In this test, potassium hydroxide is used as the strong base and phenolphthalein as the indicator. The result is captured as milligram of potassium hydroxide per gram of oil. Second preliminary test is the Karl-Fischer coulometric titration. It is a test for water content in waste cooking oil. The test is based on ASTM D6304, where the iodine is added into the waste cooking oil is equivalent to the amount of water content. Lastly, for phase 1 is the transesterification process. It is used to minimize the amount of high acid value using the single-step transesterification reaction. In this reaction, sodium hydroxide is used as the catalyst, and the final product is the treated waste cooking oil or the ester and the glycerol. At last, the treated waste cooking oil will be purified using distillation process in order to evacuate the excess of methanol. Phase 2, modified binder evaluation. Two tests that include in this phase is penetration test and softening point test. For the penetration test, it is used to determine the hardness of asphalt binder in accordance to ASTM D5. It measures the consistency of asphalt binder in tenths of millimeter. In this test, the deeper the penetration needle into the binder, the softer the binder is. For the softening point test, it is the determination of the degree of asphalt binder softness at a certain temperature under specified condition. The test is in accordance with ASTM D36, where two balls are falling apart through the sample at 25 mm. The importance of softening point test is to give awareness at what temperature the asphalt binder will attain viscosity and to recognize at which temperature the asphalt binder should be heated for the road application. Phase 3 is the asphalt mixture evaluation. The test conducted in this last phase is the Marshall mix design. It is the observation of stability and flow performance in accordance with ASTM D6927-15. In this process, the specimen of porous asphalt mixture is tested under loading deformation until failure is attained. At the same time, a dial gauge is attached to compute the plastic flow in 0.25 mm increments. The importance of Marshall mix design is to indicate the stability and flow performance of asphalt mixture at the ideal amount of treated or untreated waste cooking oil for road usage. Lastly, Chapter 4. In a conclusion, all the four objectives in this project has not yet been achieved. This is because the laboratory work will be done in FYP2. All tests and methods involved are based on JKR and ASTM standard. Attached here is the Gantt chart for the future planning in FYP2. It is started with laboratory works, which is preparation of aggregates until the evaluation of stability and flow performance from week 1 to week 6. After that, the tabulation of data and result until the completion of report from week 6 to week 11. Lastly, the submission to supervisor and coordinator is in week 12 and week 13. That's all presentation from me. Thank you.